Okay, so we're going to look at factoring what's called the difference of two squares. But before we do that, what I want to do is recap all of the ideas of factoring. Remember that when you're factoring anything, there's a series of steps, a series of questions you're going to ask yourself so you'll know what to do. Okay? If you know what questions to ask yourself, you're not going to get that lost, what do I do next feeling, right? But the only way you'll do that is to know what questions. Okay? So, here we go. You need to be able to answer these questions, so really concentrate when I'm answering yourself. When the first thing you look for when you're factoring anything is what? GCF. The GCF. Now remember, is there always going to be one? No. But if there is, you need to take it out when? First. Good. What's the second step for factoring anything?
Count the terms.
Count the number of terms. Excellent. Why? To know which method to use. Good. The first one we looked at was what? Yeah, and you use that when you have what? 4 terms. We factored using what method again? Grouping. Good. What was the next one we looked at? 3 terms, and we use the what? AC method. Good. Spent 2 days on that one. And then today what we're going to do is we're going to look at how to factor something that has exactly 2 terms. Now remember what happened when we had 3 terms? In order to factor it, we had to turn it into 4 terms, right? So factoring stuff that's bigger is actually easier. You have more choices. More things can happen to you. The fewer terms you have, the more limited you are in what you can do to them, right? Now, we don't want to turn something with 4 terms into something with 2 terms. Something with 2 terms into something with 4 terms. That would be too complicated. So what happens is something with 2 terms will only factor if it's a very special case. It has to be exactly the same format every time. Okay? And that format is called the difference of 2 squares. So what I want to do is I want to talk about what that means. Because remember, almost everything in mathematics is named after what it is, right? They don't give fancy names to something, and then you're trying to figure it out. You know what, like prescription drugs. Where do they come up with those names for drugs? Don't make any sense to me. But in mathematics, it makes sense. Difference of 2 squares explains exactly what you have to have. If you have in mathematics, what's a difference? Subtraction. Means subtraction. So there has to be a minus in these. So if you have a plus, can it be a difference? No. Okay? And think about, what does it mean if something is a square?
Times 2, right?
Well, times 2? Times itself, right? So 9 is a square. Why? Because it can be written as 3 times 3. 4 is a square. Why? 2 times 2. X squared is a square because it's x times x, right? Okay? So a square simply means something that can be written as something times what? Itself. Okay? All right. So when you're looking at the difference of 2 squares, you'll know how to factor it if you can answer 2 questions. And here they are. First, is it a difference? And difference again means what? Subtraction. Okay? What if it's not subtraction? Then it's not a difference, it won't factor, and anything that won't factor we're going to call prime from this point forward. It simply won't work. It's prime. Okay? So, if I have a plus in the middle of 2 terms, prime. Don't even have to think about it. If the answer to the first question is no, then I'm not moving to the second question, right? Okay? Second question. Are both terms, because there's only 2 of them, right? Perfect squares. Now, The title just says squares, and I put perfect square because I really want to emphasize it. What a perfect square means anything that can be broken down as something times what? Itself. And it can be a number or a letter or a combination. Is 4x squared a perfect square? Yeah, because 4 is 2 times 2, and x squared is x times x. So 2x times 2x would make 4x squared, right? As long as, if you have a number and a letter, as long as both the number and the letter are perfect squares, then that whole term is a perfect square, right? And the only way to recognize that something is a perfect square is to have your brain say what number times itself would make that number, right? So, if I ask you, is 16 a perfect square, what would you say? And how do you know that? 4 and 4. So you've already done the math, right? That's the only way to be able to tell a number is a perfect square is to actually kind of do the math in your head. So, if you know that, then you already know how to do these, because it's simply a pattern. Okay? All right? Now, if you're looking for the number times itself that makes a square, that number is called the square root. So, the square root of 9 is what? 3, right? So what would be the square root of 16? 4. What would be the square root of x squared? Plain old x, right? So when I write the phrase square root, you'll understand that that means the number that you're looking for, the number times itself that made your original. Okay? You okay with using that term, square root? So here we go. If it is the difference of two squares, then here's the pattern. You get the square root, I'm abbreviating here, of the first term plus the square root of the second term. That's what goes in the first parentheses. This takes longer to describe than it does to do, trust me. And in the second parentheses, you're going to get the square root of the first one minus the square root of the second one. So in other words, the numbers and letters in the two sets of parentheses that you get are identical. The only difference between these two sets of parentheses is the first one has a what? Addition or plus. The second one has a negative, minus. And that's it. So the pattern is really good. Let's look at some examples so you can see this. This is one reason I always save this to the end, because it's just a pattern again, and so you'll just learn the pattern. Now here's the big problem though. This pattern is so easy that from now on, every time you see two terms, you're going to want to make it work. Because once you get something that's easy, you want to use that one all the time, right? But it doesn't always work. It only works if first it is a what? Difference, and second they're perfect squares, right? So look for the difference first. Okay? So, v squared minus 81. Is there a GCF? How many terms? 2 terms are the only factor if it's the difference of two squares. Is this a difference? Yes, because it's minus. Is v squared a square? Is 81 a square? So our pattern is, what times itself is v squared? So I get a v here and a v there. What times itself is 81? So I get a 9 there and a 9 there. First parentheses gets a plus. What's the second one get? And that's your answer. Okay.
So if it's positive, would that just be prime?
Yeah.
Just leave it?
Mm-hmm. Yeah. What if I had v squared plus 81? They're both perfect squares, but is that good enough?
No.
Because it also has to be a what? So this one is prime. In other words, it won't factor.
So that's all we have to put.
It's prime. Okay? It's same numbers, So shouldn't it have worked if you had the same numbers?
Adding.
No, because the difference is here. And I promise you I'll get you on the test if you don't practice that. Got to be a difference. Doesn't matter if they're squares, does it? Because these numbers in this one and this one are the exact same numbers, but this one factored and this one did not. Why? Because there's a plus between them instead of a minus. All right, look at this one. A squared minus 2. Difference of two squares?
Yeah.
See, your little mind wants it to happen so bad. Is it a difference? It's a difference. Is a squared a square? Yes, but what about 2? There's no number times itself that would make a 2. So even if even one part of it can't be answered, yes, then it's automatically prime. So be careful. A squared minus 164. Is it a difference? Yes. Is a squared a square? Is 1 over 64 a square? Yes. Yeah, any fraction is a square as long as both the top and the bottom are both squares. And 1 is a square because it can be written as what? 1 times 1. 1 is the only square that can be written as itself. So, what's the square root of a squared? What's the square root of 1 over 64? 1 over 8. Right. Because 1 is 1 times 1, 64 is 8 times 8. So you can do fractions. First one gets A, second one gets A, and there's your answer. Okay? This is the only place I would ever give you fractions in factoring because they have to fit the pattern or you can't do it. Oh, there's a lot of fractions in this one. Let's look at another one.
How many questions total?
Mm-hmm. I don't know yet. I can't tell from this particular screen. He always has something better to do, so he has to know how much homework to do. He's got so much to do. I got no life outside of math. How sad is that? All right, here we go. GCF? Yeah, there's not going to be a GCF with their fractions. All right, how many terms?
2.
Difference?
Yes.
Squares.
Yes.
Oh, whoops, sorry. It would be if I wrote it right. Sorry about that. Squares? Yes, sorry. That wasn't the first time, was it? But it is now because I write it right. So what's the square root of 36m squared?
6.
Yeah. Doesn't matter that you have a number and a letter. Just take the root of each part of it. What's the square root of 25 over 9?
5 over 3.
First parenthesis gets A. Second one gets A. And that's your answer. So how nice is the difference of two squares?
Well, because it's easy, it means it's going to have all the questions for homework.
Yeah, there were a lot of them. Of course, you know there were. Okay. Now, sometimes this course compass thing will give you numbers that are very large.
Yeah. Calculator.
So, make sure, first of all, that if they're very large, that you should look for a common factor to see. Let's see, 11, 12, 13. So these don't have a common factor. But, so have your calculator, and so to see what you can see what number times itself would make 256. If your calculator has a square root key on it, do those basic calculators have the square root key? No? Okay. But remember, in this course, you don't have to have just the little for function. You can use any calculator as long as it's not a... What? Graphing calculator. Good job, kids. Can't be a graphing calculator. Remember, I'm going to be looking on the test, too, if you have a graphing calculator. So you can use a scientific one in here, whatever calculator you want to use. Otherwise, just start multiplying numbers times themselves and see if it'll work, right? So, 256. Yeah. 256 can be broken down to 16c times 16c. Is there anything times itself that makes 361?
19.
It's 19 and 19. Yeah. So, these, I can't do anything about the fact that they're going to give you big numbers. I would never do this to you on a test. All right? And then we get a plus and a minus. So don't panic. You have time in your homework to sit there and multiply it out, or hit the square root key, whatever you need to do to get this to get the right numbers. So So don't just think, those don't look like 9 and 4 to me, so I'm going to skip it, or I'm going to say it's prime. Okay? Really look out.
So the variable always has to have a square or it doesn't work?
Right, because otherwise, if it doesn't, it won't be squared. Now, it doesn't always have to have a square. It could also have a higher exponent. Okay, let's look at this one first. 9x squared plus 16. Difference of two squares? Yes?
No.
Do you see what I'm saying? When it's easy, your little brain is going to want to make it work so bad that it's going to make everything the difference of two squares from now on. Why is this one prime? Okay? Now, also be careful. Listen, if you wrote this instead of prime, I can't give you any partial credit for that, right? You are completely wrong. Whereas like in the AC method, if you multiplied and got a negative and you should have got a positive or something, I can see that kind of, and I can watch the signs. I can give you credit for what you did right. But do you see this? There is nothing I can do if that's your answer. So in other words, the entire thing is wrong. There is no partial credit to give you. So you've got to be careful. I have to count the entire thing wrong if you get it wrong. Because there's no work, is there? Everything you did was wrong. So you've got to be really careful. Okay? All right. Let's see. Oh, there are only 10 of these.
Oh, really?
Yeah. Look at this one. Is there a GCF? No. How many terms? 2 terms. Is it a difference? Is a to the 4th a square? Yeah. Remember, any exponent is a square as long as it's even, right? So a to the 4th, a to the 6th, a to the 8, any of those would be squares. So is 25 a square? So what times itself is a to the 4th? Yeah, so it's a squared and a squared. What times itself is 25? First one gets a plus, second one gets a minus. Okay? So be careful. Another place you need to be careful. 16w squared minus 196. Difference of 2 squares? Is 196 a square?
Yes. 14 times 14.
Okay. So this would be 4w plus 14 and 4w minus 14?
No.
What is the first thing you look for when you're factoring anything?
GCF.
Is there one?
Yes.
Both of these will divide by at least 2, but try 4.
Yes.
Right? And if you didn't divide that 4 out, even though they are perfect squares, if you don't take the common factor out when? At the beginning, first, then everything you do after that is wrong. What is that, 36? Now, the thing inside is the difference of 2 squares. So what do I do with the 4? Bring it down. You're going to keep it. And what is my final answer? 2w plus 6, 2w minus 6. Ooh, wait a minute.
How'd you get 36?
That can't be right. Is 36 right?
No, it's
What's
49.
It's 49. There you go. That can't be right. Thank you. So it's not 6 but 7. Let's just erase that whole bit and do that again. 16 and 196 will both divide by 4, right?
Yes.
So divide them by 4. 196 divided by 4 gives you 49. Sorry. I can't do the math. I can teach it though. So then, what do you do with the 4? Keep it. And you get 2w plus 7, 2w minus 7. It helps if you use your calculator. Make sure you get the right numbers. All right. It's not fair. I don't have a calculator up here. Maybe I should bring one. Okay? So, if there is a GCF, even though these were both perfect squares before you did it, what would be right? What would happen if you didn't take that GCF out first? Your answer's wrong. So you've got to look for the GCF when? First. Right? Okay. So that brings us to the end of all of our factoring methods. That's everything we're going to look for. So you're going to have 2 assignments for this section. You're going to have one assignment where all you're doing is looking for the difference of 2 squares. Is it always the difference of 2 squares? No, sometimes they're prime. They don't work. Okay? And then you're going to have a second assignment where you have everything that we've learned about factoring all mixed together. Now, let me warn you here that you've got to really know your methods in order to make this work. This is perfect review for the test. Okay? So, remember that when we first started, sometimes all you could do was take out the GCF. The first day, that's all we could do. So, some problems, even though you can try the AC method or difference of squares or whatever, all you can do is take out a GCF. Now, if that's all you can do, is it prime? No, you still factored. You took out a GCF. That's still under the rules for factoring, isn't it? So that's still factoring. But you remember, always take out the GCF when? First. Then look to see how many terms it has in it and know which method to use. How do you know when to use grouping? How do you know when to use AC?
3.
How do you know when you have to look for the pattern difference of 2 squares? Okay? So the problem will tell you what kind of factoring it is. But after that, you have to tell it what to do, right? The only thing the problem can do is tell you what kind of problem it is. But you have to determine which method to use, and you have to memorize which steps. And so that's why it's important that you get that one done, so that because I'm going to give you a review day for this one, because this topic is so important. So on Tuesday, we're going to review. So you come in here and you haven't done your homework, and you ask me questions, I'm going to give you an attitude. You come in here and you've done your homework, but you've got questions, that's fine. But get your homework done. If you're behind, you don't have anything else to do this weekend, get caught up. You better not have anything else to do this weekend, because you've already wasted the other time, right? If you've already taken days off, then you don't got any more days off to take off. You've got work to do. So you better get it done, right? Stay on target. If you're not, I'm going to start emailing you constantly. And just driving you insane. Because I don't want you not to pass this class just because you've gotten behind. Right? Take it seriously. College is not a game. All right? Then, let me call the roll. And y'all can go. Let me do the assignment first, though.